Hello and welcome. This is Barrett from the C4 Cyber Club here at Cypress College. And in this video today, we're going to cover the Ethical Hacking Lab series, Testing Firewall Rules with Firewalking. So, firewalking is essentially a tool that we'll be using. And we're going to see if we can evade specific firewall rules like access control lists, for example, and what happens when they aren't set versus when they do eventually get set, and how do our results differ, right? So you may be thinking, okay, well, what is firewalking? Get to the beginning of the lab here. So we will be working in the OpenSUSE machine in this lab, and we'll need to launch Firefox to access the pfSense admin for the firewall rules. But before we get into that, I want to talk a little bit about what firewalking is. And I actually found a really nice blog that details almost, I kind of have a feeling it was related to this lab as well. So I recommend this defensive-stance.com. It's a blog by Amy Hayen. So shouts out to her. I'm just going to really wanted to use it for a couple of the images that are really useful. So essentially firewalking, it works a lot like the trace route command. It utilizes the time to live, or TTL, also known as hop limits, that you'll find in IP header information. So when routers look at TTL, or time to live, if the value is not set to 0, the router decreases the value by 1, and it will continue forwarding the packet onto its eventual destination address, right? So the important part is when the hop limit reaches 0, the router sends back an ICMP time exceeded message back to the sender. And so with firewalking, the firewalk tool sends packets one at a time, and it keeps increasing this time to live value until it finally reaches a target. And then once it reaches the target, actually here's a really good image as well. Once it reaches the target, it increases that time to live one more time, and then it's going to begin the requested scan that we set. And this is where we'll see if it doesn't get a response, you could assume that whatever you tried to send it is being blocked. Or in the case of this lab, we're going to look at how the very first time when we scan, there's no firewall rule set. There's no access control lists. So we'll take a look at a scan in that regard, and then we'll actually set some firewall rules very specific to certain protocols, and then we'll see how the results differ. So you'll begin to see how your results differ depending on if specific firewall rules are set, and how you can determine if firewall rules are set. So if you're doing this would be definitely considered active reconnaissance. You're actually sending packets, and then you will either determine, okay, is there rules set? If there are no rules set, that could be very useful information. And also on the blue team side, if you just want to scan, make sure that your firewalls are up to par. They have all of the proper lockdowns. You could use something like firewalking from inside your network. So hopefully this image reviewing IPv4 header packets, and I do invite you to go to defensive-stance.com, take a look at this firewalk technical blog write-up. It's very useful for this particular lab. So let's go ahead and get into the actual lab material. So just a reminder, I came into the OpenSUSE machine and I opened up Firefox. And we will go to 192.168.0.254, which is the pfSense firewall here. And we will log in as admin And it looks like it autofills, but just in case yours doesn't, the password is pfsense. All right, so now that we're logged into the dashboard, let's take a look and see what kind of rules are set currently. So we'll go to Firewall, Rules, and now you see something that's not really good, right? It's allowing everything. These asterisks mean that everything's allowed, anything on IPv4, all ICMP packets are explicitly allowed. So right now there is absolutely nothing really blocking, there's no access control list, there's no rules set. So let's take a look at what that looks like on a scan. So we'll move over to the Kali machine. Just go ahead and logging in now. And we'll open terminal. And the first thing we could do is just type in Firewalk. And this will actually just display help and show you the different options you have. So you could set specific interfaces. We are going to use the -n, I know in this lab, to do not resolve IP addresses. So this is often very useful, especially if you're doing active scanning, active reconnaissance. You want to be as quiet as possible. So there's no need for us to do that. So it's best to leave those kind of requests out. We can choose between TCP, UDP, choose source ports, all this stuff here. And we could also set that time to live option as well. All right, so before we do Firewalk though, let's take a look at a standard Nmap scan. So we are scanning the firewall from the Kali machine here. Okay, so you can see this does tell us that these two ports are open, 53 for DNS, 80 for the web server. But it doesn't really tell us anything about, give us any information about a firewall or gateway. We don't know if there's access control lists set up within a firewall or within this device. So that's where Firewalk comes into play. And you can see the lab does break down the commands really well. So you can see the -n, don't resolve name, the host or the DNS. -p, we're setting the protocol to TCP. Scan ports, so we'll use 23. Destination is 23 as well. So we're scanning telnet right now. And we select the firewall IP address and then the target. So we're hoping to scan beyond it. So this is technically the target here. All right, so let's type that in. Okay, so that returned back pretty quickly. Now we see, so it uses 192.168.9.1, the firewall, using .12 as a metric. So this is basically looking for an ACL related to this metric. So we see port 23 open, but port not listening. So as you can see in the lab, this means that even though the port is closed, the rule is not in place. There is no rule in place for port 23 specifically. Because remember, when we looked at here, there's no rules for any protocol specifically. And if I press the up arrow, the lab has us do the same exact scan, but on port 25. And I'm sure you could probably guess we're going to get the exact same kind of output here. All right, so now let's do a firewalk where we actually do a range scan. So we'll say ports 53 through 80. All right. So you see it gives us the output on all of these. So none of these ports are listening, so they're not open. So there's no access control lists there. Also, there's no ACL on port 80, but it does note that this port is listening though. So it's open for communication, which makes sense because if you're running a web server, you need to allow people to connect to it to load up, web apps or web pages. All right, so now we'll move back into OpenSUSE and into the pfSense administration here. And you'll notice this icon here for edit rule. So we're actually going to edit this current rule here that's totally wide open. So let's go ahead and edit that. We're going to change the protocol to TCP. And under destination port and range, we'll change this to HTTP port 80. Go ahead, hit save. Always remember to apply changes here. And now you see that that's instantly been applied. Now we're specifically allowing only port 80 at the moment. Now let's do the same. We can choose this icon here, add a new rule based on this one. So we'll kind of copy over some of the similar things. You see the protocol is already set to TCP. It's set to HTTP, port 80, but we want to also add 443 for the secured version. Apply changes. Now you see we have two rules. And let's go ahead and add port 53. And on this one, since DNS is UDP, we need to change the protocol. And we'll change this to DNS down here. Go ahead and press save, apply changes. Okay, great. So this is a very typical setup here. It's going to be allowing all three ports here and nothing else. So let's go back to Kali. Go ahead and clear the screen, and let's try running Firewalk again. Oops. Okay, so you see it's going through this ramping phase. It's responding to the ACL rules that are in place with this no response. And remember that port 23, we had absolutely no rule set for that. So that is completely blocked. Now let's go ahead and change to port 53. Looks like the same scan. And now we're pretty much going to see the same results because even in the lab, how it says the ACL role is set for UDP on port 53. And in this scan here, we're actually sending TCP or requesting TCP. So this is pretty obviously going to give us the same no response. So I'm actually going to Control C out of that. So let's go ahead and change this to UDP. And actually, let's double check, make sure that both of these are set to 53. And now let's go ahead and try this again. Okay, and that actually comes back super quick. And what we see here, we have this ICMP port unreachable. So this is where we're using Firewalk to determine that a rule is in place for this port 53. So and remember what I said in the beginning is actually very useful on the defensive end, on a blue team side, because you can double check your firewall rules without actually needing to maybe go log in and check the rules manually this way. It could be just a command line tool away. So that concludes this lab, Ethical Hacking Lab series, testing firewall rules with firewalking. Thanks a lot for watching.